All right, so number 6 says sketch the graph, and they give us an equation or function by finding the vertex, solving for the x-intercepts, and identifying the y-intercept. So we're actually going to put together a couple different ideas. I can always get a sneak peek at what this is going to look like. So I can always graph this, and I could just throw that in there. So let's see, x squared minus 2x minus 3. Again, it's not cheating, right? Oh, we need to clear that out. We don't need all that action in the exponent. So x squared. So again, though, but it's not cheating, right? So all we're trying to do is we're just trying to get a sneak peek of what we think the answer should look like. And this is a way for us to maybe catch ourselves from making a mistake, because if we already kind of know what the answer is going into it, and then if what we get doesn't match, then we can be like, okay, well, we made a mistake. So let's see what this should look like. So we'll take a look at a graph of it. Okay, so we got a parabola. Looks like the vertex might be right where it bottoms out right there. Looks like the vertex might be 1. Let's see, what's that? -1, -2, -3, -4. So it looks like the vertex is maybe 1, -4. They're asking for a couple different things, right? So they're asking for what is the vertex, what are the x-intercepts, and then what is the y-intercept. So just by looking at the graph, I could kind of already answer a couple of those questions. Looks like the vertex is going to be at 1, -4. Looks like the x-intercepts, looks like it touches at -1 and +3. And then the y-intercept looks like it touches at -3 right there. So I already kind of have an idea of what the answer is going to be. Let's get in there and actually figure out what it is. So how we're going to do that by hand is that we're going to take the equation they give us. To find the vertex, there's actually a little formula we're going to use. So to find the vertex, our little formula that we're going to use is x equals -b over 2a. Right? And so what are we talking about when we say a, b, and c? Well, when it's in standard form, right? The other, number 5 was vertex form. You'll notice the difference here. Vertex form, you see parentheses, some quantity squared, and then some number at the end. Here you notice there's no parentheses, right? So this is in what we call standard form. And the numbers, we'll just say that's a, b, and c. So what this gives us is that it says, well, take the opposite of what b is, which in this case is a -2, and then that's over 2 times a, which is 1. So the two negatives will make a positive for us. So 2 divided by 2, and I get 1. So the x value of my vertex is going to be 1. And again, here's the value of already kind of knowing that. We already said that the x value of the vertex is going to be 1. So had I made a mistake here, I could have already caught myself. Let's find the y value of the vertex. So what we're going to do is that we're going to take the equation that they gave us, y equals x squared minus 2 times x minus 3. And then all I'm going to do is I'm just going to substitute that x in. So we know that x is equal to 1. So I'm going to drop that in. So 1 squared, 1 times 1 is just 1. That would give you 2, and then we've got minus 3. 1 minus 2 is a -1. -1 minus 3 is a -4. Okay. So again, so this checks out as well. So there's my y value. So my x value of the vertex, which is 1, and then the y value of my vertex, which is -4. So what I could do is I could put those two things together. So my vertex is going to be at 1, -4. So I could actually go ahead and mark that point. Now again, no surprise. We already said it was going to be 1, -4, right? So we're just verifying by hand what we've already done using technology. All right, so the next thing they're asking about is they're asking about the x-intercept. So we got the vertex, we're good there. They're asking about the x-intercepts, right? So there's two ways you can find the x-intercepts. You can factor, or you can use the formula. So we'll say factor or formula. Now, this one actually can be factored, and we're actually going to have to use the formula in a later video for a later problem. So let's factor it from here. The way the factoring setup works, and we have this little, some people call it an X, some people call it a diamond. So we have this little tool that helps us organize this stuff. So basically what we're doing is to factor this, which again, this is our original equation. We're looking for two numbers that multiply to the top. So we want it to multiply to the top. So multiply, and then we want those same two numbers to add to the bottom. Right, so let me show you what I mean by that. So what we would have is that you would have a times c, which is 1 times negative 3, which would be negative 3, and then b, which is negative 2. Looking for two numbers that multiply to that also then would add to that. The only thing that multiplies to 3 was 3 and 1. Now I got to figure out how am I going to make that add up to a negative 2. Well, how about negative 3 and positive 1? Yep, that checks out. All right, so I take those numbers. Those go into the parentheses for me, right? And then those are going to be my two factors, right? And what I could do is I could check this. If I did x times x, I get x squared. If I did negative 3 times 1, I get negative 3. And then if I did x times 1, which is 1x, negative 3x, and I add those two together, I get negative 2x. So with factoring, you can always check your answer. Now, since we have two factors, right, because we have two places, right, where the parabola crosses the x-axis, so we're going to have two x-intercepts. So we're going to separate these two things apart and then solve for each x. So I've got x minus 3 equals 0, and then I've got x plus 1 equals 0. And just a little simple baby little one-step equation to solve. And we get x equals negative 1. So again, no surprise. This is what we predicted, right? So we predicted that I would have, so x equals 3, x equals negative 1, right? We predicted that that's what it would be. X equals 1, 2, 3, x equals negative 1. So now the last part that that they're asking about, so we're done there. Last part they're asking about is the y-intercept. The y-intercept's real easy, and actually you get this one for free. And what I mean by you get it for free is that you don't have to do anything. You just look at it, and you know what the y-intercept is. Let me mark these 2 points. So what the y-intercept is just whatever the last number is. So in standard form, y equals ax squared plus bx plus c. Whatever the last number is, that's going to be your y-intercept. So you don't have to do any work, no formulas, no factoring. You just look at it. So if I look at this, the last number is a negative 3. So that's going to be my y-intercept. So I don't have to do any work. I just mark it, negative 3, which would be right there. All this does, it just gives me kind of an extra feel for how to draw this parabola, right? Because what I want to do, if I just know the vertex, which is what we had on the last one. See, this was somewhat inaccurate because we don't know exactly where the parabola shoots up through the x-axis. Here, I know exactly how to draw it because I could know the vertex, but the x-intercepts give me a guide as far as how narrow or how wide it's going to be. Because I could have a vertex here, but I could have a parabola that swings out really wide, or I could have a parabola that's really narrow. So the x-intercepts give us a guide as to what exactly that should look like. All right, so there's our 3 pieces, and we've got our parabola now graphed. And again, we did this side by side because sometimes we get stuck in factoring and solving, and then we forget what these numbers represent. So again, these numbers represent our x-intercepts. All right, so go ahead and stop the video now and try number 6.